volume, velocity, veracity. All right, and what else is there? What is the other V? Volume, uh, velocity, veracity. Then there's one more. The fifth one we are not bothered. A variety. And the fifth one is the value, which we are not addressing it right now. Okay. So remember volume, velocity, variety, and veracity. All right. So then I was explaining about a lot of applications, use cases for big data, which some of you will be familiar from your UG course, big data course. Okay. Another quick update for you on the textbook part. Like I mentioned, that black book. Okay. Let me show you that book one more time. All right. So this particular black book, right, which I said will is available in the library. Okay. So there are only two copies. I have one book, and the other book they use it as a reference book. All right. So that is the update. So if you still insist in checking out, you have to talk to the librarian, and somehow I think he will allow the students to check out with a shorter duration probably, or you guys can do Xerox, or you can order. As I said, it's available for like 875 rupees. So sometimes they quote 1,000 rupees or 1,200 also. Right now they are quoting 875 rupees. Okay, this is a very good book. It will be useful for you for now as well as for your future projects. Okay, so that is the update. So let's move on. All right. Okay. So we have looked at various use cases and so on, the structured data, the semi-structured data, the unstructured data. So where big data has to process all different types of data formats. Okay. So they'll have to even process like um, uh, data in different formats, but also they have to store it in the cloud or in some storage in different formats like row based storage, column based storage, and so on, or row and column both. These things not only for processing data, there's something called data ingestion. Okay, ingestion. That is INGES, not INJUNC. Okay, INGES, ingestion. So where it has to obtain or acquire the data from different sources in different formats and store it in storage in different storages or different types of storages, and storage also have to be done in different formats. So you have to remember all these things. It is quite flexible. The big data architecture and the tools are quite flexible to deal with all kinds of data and all kinds of storages. Okay, so some of this scalability and parallel processing we all will look at it little bit later. It's just um, basics that we are talking about. So it has to address scalability, that is large volume of data, and parallel processing. So those who are familiar with the map reduce problem, you will know that how the particular problem or a given problem or data is broken down into various smaller chunks. Okay, and they're all processed independently, and they all execute in parallel. Then the results from each um, process is collated, combined, and then that's the map reduce, right? Then the solution is provided in the required format by the reducer process. So there can be more than one map processes. There can be more than one reducer processes. So parallel processing is extremely important uh, to finish up the processing quickly because we are dealing with large data sets. Okay. The other one is, I think it's mentioned here. Yeah, the scale up and scale down, then scale in and scale out. Okay, 1 minute. Um, let's see if I can enable my pointer. It's easier to do it in Microsoft Paint. Okay, I think I'll switch to Microsoft Paint. Not this. I think I can use this. Okay, it takes time. Instead of wasting time, I'll go back to the same thing. I just need should be somewhere here, or I'll point it with my cursor itself for now. Next time I'll use my PowerPoint piece so I can do write something, underline, do all those things. Okay, so you have to understand the difference between scale up. Okay, then of course you know the difference between scale up and scale down. So scaling up is where you increase the capacity of the server or a particular resource. Okay, scale down is to decrease the capacity of that resource. So for example, on a server you can increase memory, CPU, power, storage, and so on. So scale up and scale down. But scale in and scale out. Okay, so scale out is like adding more servers. So it is like horizontal scaling, whereas scale up is vertical scaling. You are only dealing with this in a same server but increasing its capacity. In scale out or horizontal scaling, you are adding more power by adding more servers. Okay, so that's the difference. So all these are actually handled by cloud automatically. So that's why big data uses cloud. Okay, so otherwise it's very difficult to scale up and scale out outside cloud. So some admins have to do it. Okay, whenever more resources are needed, some admins have to add, and then big data processing has to restart, and all those things. It'll be a nuisance. Whereas in cloud, auto scaling is happening. So scale up, scale down, scale out, scale in. All those things will happen automatically. Okay. So the goal is to run the processes in parallel, finish the analysis part quickly. Okay, and then to handle more workload. Okay, so that's the um, purpose of mainly that is the goal of big data, right? To increase the workload or handle more workload and quickly come to some conclusion after analyzing the data. Okay, so as I mentioned yesterday, the data can be real time or it can come from any source. It can come from database, it can come from any other log file, audit file, anywhere. All right, so I'll move on. If there's any question, like I said, interrupt me, ask me question. I won't notice if you are um, texting or anything. I won't notice it. So interrupt me if suddenly something is not clear, or if my screen is not visible, or if I'm not audible. Okay. All right. So that's why we have this something called massively parallel processing (MPP). So basically, it's not just parallel processing; it's massively parallel processing. So large amount of data, unimaginable size of data is being handled and then processed in parallel across various distributed systems. Okay, so of course cloud handles all these things, but this can be done outside the cloud, provided if the tasks run by any big data um, application. So let it be MapReduce or any application, or Hadoop or Spark, any architecture, right? If the tasks can be separated and they can be run on separate threads on the same CPU. So basically, they have to use the power and advantages of threads on the same CPU. But again, you are limited to the capacity of that server. Okay, so you can do a little bit of parallel processing. The other one is running the tasks on different CPUs. So nowadays you quad core, hexa core, octa core, they are all popular, right? So each computer having multiple CPUs. So the tasks can be distributed across the CPUs, which means one set of tasks. So let's say a mapper process that takes, let's say, half an hour or 1 hour to to process or analyze the data. Okay, so that can be running on one CPU, and another mapper process can be running on another CPU, and so on. So by using all four CPUs, they can speed up the execution of all these processes. So basically, they are doing parallel processing. But the most common one these days, because of the time and size of humongous data, is to run tasks on separate computers. So again, cloud or some virtual computing will be useful. So they can use any computing, cloud computing, grid computing, virtual computing, distributed computing, whatever provides the resources. What do the processors need? Just CPU, memory, and storage, right? So if they can do this distributed way of running each task on a separate computer, that will also parallelize all the tasks. Okay. So, what do we mean by big data architecture? See, there's no big architecture diagram that we can draw to represent a big data architecture, right? So even for cloud, right? Cloud is just putting together a lot of heterogeneous components, and that becomes the cloud architecture, right? So even similarly, a big data is putting a lot of things together. Basically, it's just putting all the servers together, distributed servers together. But here the tasks are or the architecture basically will run different types of tasks. So it builds architecture as something like OSI layer in networking. So it has various layers, and each layer is responsible to do separate tasks. So basically, you are making the architecture very granular, and you can do a lot of parallel processing, and you can speed up the execution. Okay, so basically it uses the same thing: CPU, storage, and memory. So we call it hardware. Then that is the hardware: CPUs, memory, and storage. Then you have the database. It has to work with the database or any storage, plus all the associated software. So OS alone is not enough, as you know, to process all the big data, all the huge data sets. You need a lot of other software or tools, big data tools. Okay, plus any security, additional security needed, all those things. So like maybe encryption may be needed while while storing the data, or while after the data is retrieved, right, from the source. Then before it can process, maybe it has to do some encryption, because it has to read the data from different sources and store it somewhere before it can start the processing. So that storing may require encryption before it can process. Sometimes it will process the data, then encrypt and store it. So it all depends on the business requirements and security requirements. All right. Okay. So let's look at this layer. So as I said, there is no architecture diagram as per se. Even with cloud, there is nothing like architecture diagram, just putting all the pieces together. but there you can have some representation in cloud, like you can have the entry point, you can have the middle layer, you can represent the VPC layer, virtual private circuit layer. You can represent um, the instances, virtual instances. The If you are looking at AWS, you can look at some buckets like storage for storing the data, the EC2 instances, all those things you can at least represent. But here, big data, you can't represent anything because it's just the server power. So, but we still call it big data architecture, but it's nothing but different layers. Okay. So today we'll just spend time on the on these five layers. Okay. In OSI, of course, so you had seven layers, but it was totally different. But the concept is the same, where each layer will so let's look at layer one. Okay, so layer one, what it does is identification of internal and external sources of data. So the big data architecture and the tools have to pull out data from various sources. Some sources may be internal to that server or to that environment. Some sources will be external. It has to pull out data from outside. Okay, so even from internet or even from cloud, even from some storage, which, let's say, some ML algorithms did some pre-processing and then stored it on particular storage, and then big data can go and analyze that stored data. So whatever may be the source, so it has to pull that. So that is the ingestion, sources for ingestion of data. That is pulling data from different sources. Okay, and as I mentioned already yesterday and today also, it has to pull the data in different formats: structured, semi-structured, unstructured, everything that explained. Okay, so it's simple. Layer one is simple. Okay, so next layer two, then what does big data do after it pulls the data? Okay, so there are two things. One is ELT, that is extract, load, and transform. Okay, I don't know if I can write somewhere. Okay, I just use Notepad for today. Tomorrow I'll use PowerPoint. Okay, there is something called ELT and the other one is called ETL. Okay, so both are almost similar, but the sequence of operations are different. So extract, load, transform. The other one is, some of you who are over studied big data basics, right? And would know about this. Transform, load. That's all. So what it does is the big data tools, when it pulls the data, that is extraction, then it can load it into some storage before it can transform that data. Okay, so load it. Let's say it loads it in cloud. Okay, then it does the transformation. Basically, it'll apply all the transformation rules. The transformation rules can be anything. It can break down the data sets into various smaller buckets based on various parameters. So I'll just give very simple example and then we'll move on. We'll cover more of it later. Okay. So let's say if the data is related to customers, okay, customers and their age, name, age, number, whatever customer product related, what are the products ordered by customers, so on and so forth. But let's say this particular application or there is a use case to find out what age groups the customers fall into and which age group is ordering which product and that kind of information. Okay, that is very common use case these days for marketing purpose. So then it will pull out all the age related information and then all the data related to, let's say, ages between 10 may be too early, maybe I'll put 15 to 25 age group. They have ordered all these products. So product one, two, so on and so forth. Okay. Similarly, age group between 26 to 30, like that. What are the products ordered? So if this is the use case, then the transformation will happen such a way that the data pertaining to this range of ages, right? Age 15 to 25, 20, 30, 30, 31 to 40, like that. So they all the data will be transformed and put into different bins or buckets. Okay, we'll look at all this thing a little bit later. Bins or buckets. So basically, separate location. Okay, first the data is transformed like this. Then the additional processing is done on each of these bins in parallel to extract more information, then for classification purpose and so on. The other transformation that could happen is encryption for security purpose. Maybe the data is loaded and encrypted immediately, and then processing can be done later. Okay, so that is ELT, and the other one is ETL, which it will do the transformation, whatever it needs to do. That I can explain here: bins, buckets, then encryption, all those stuff. Okay, then it will do the transformation temporarily. So that is called the staging area. Are you able to see my notepad? Can you confirm?
Yes, sir.
Yeah, thank you. So the transformation can happen in the staging area. Okay, so it'll do everything. Then it will move that humongous data from the staging area to load. Then move it to storage. Let's say it's permanent storage. Okay, then maybe further processing could be done, or maybe that is the end of it. So that storage will have the final transformed result, or final result, whatever is needed. Okay, or if further processing is done, then the data will be pulled out of the storage. So that's it. So that is the ETL and ELT. Okay, so here ELT is represented, but ETL is also available or supported. Okay, then semantics, whatever additional, uh, like it's, you can call it pre-processing. Okay, some replacement, some appending, some information or data need to be appended, some data need to be aggregated, maybe while gathering, or when the data is injected, right? Then the data can be appended, replaced, aggregated. All those things can be done. Okay, you can call it pre-processing if you want to, but based on certain language or semantics. Okay, let's say if it is healthcare related data, right? Maybe they want to combine all the patients into one particular illness group. Okay, so then they can do further processing later. Then they can extract data age wise, and severity of the illness and so on. So something like that. Then pre-processing, you guys have known because you have done ML course. So all any kind of pre-processing, validation, again transformation can be done, encoding, transcoding, whatever needs to be done with data that was ingested or acquired, right? That can have a lot of redundancy also, which may not be useful. So cleaning up can be done. Okay, filtering and all those things. And again, the data can be injected. Okay, so that's about layer 2. Then layer 3 is about the storage. So storage, stored in module 2. Okay, so Hadoop distributed file system, it is like another file system. We all know about Linux file system, ext file system, then Windows file system, NTFS, right? This is Hadoop file system. It's designed specifically for. So there are other architectures like Spark. They all support HDFS. It's called HDFS, Hadoop Distributed File System. So we will HDFS, Hadoop or Hadoop distributed file system. So you can store the data there. And again, as I said, nothing is um, done or reaches final state because the data keeps on getting picked up and processed for further and further use. It's not like you process it once and then say, okay, we are done, we got all the details, because there are lots of research done to improve the algorithms, to improve the big data tools, then to based on the marketing requirements, business requirements, the same data will be accessed again and again and processed in a different way for various to meet various requirements. Okay, so for those things, HDFS will be useful rather than storing it in like this MongoDB or Cassandra and so on. Okay, MongoDB and Cassandra will also support large data, but they have some limitation. So HDFS is much more scalable. Okay, so HBase is also their database. So your data can be stored in Hadoop base. It is HBase. So you can store it in NoSQL data stores, all those things, right? So this primarily layer 3 deals with data storage. Okay, again, certain things are repeated, like the data can be compressed or it can be uncompressed, or maybe it can be historical data or incremental data. So all kinds of data, like real-time data, all kinds of data, they all can be processed and stored. Okay, so layer 4 will deal with actual processing. The other layer 2, layer 3, they kind of do pre-processing. Okay, so this is for ELT example. So where it extracted and loaded into storage, we did some pre-processing and loaded into storage. Then comes the transformation or actual processing. Okay, but the same logic applies for ETL, where it has to transform and then load it. Okay, so just remember, but we'll just go with whatever is um, given in the textbook. Okay, rather than looking at all various possibilities at this point of time. Okay, now the actual processing can be done. As you know, I think at least two of the students said they have already studied big data in UG, so they'll know MapReduce, they'll know Hive for processing. Pig is another tool for processing data. Spark is the big data architecture that will also do a lot of parallel processing, and it will do. It is used for performance. Spark does a lot of processing in memory itself. It has huge. The Spark architecture uses large size physical memory. Okay, so a lot of processing is done in memory itself. So, and it stores a lot of data in memory itself, rather than processing in memory and storing it back to the permanent storage, like OS does, like other databases do. Spark will use memory itself for storage. So that's how data retrieval will be faster, data storage will be faster, and so on. But it requires humongous size, memory size, physical memory size. Okay, so but anyway, Spark achieves a higher performance by using in-memory computation. All right. So if you have studied this in UG, good. Otherwise, we will revisit it in the in this course also. Okay, Spark, Hive, Pig, Hadoop, MapReduce, we'll all revisit. All of them will be revisited in this course also. Okay. So data processing done using these techniques or architectures. There are tools for everything. There are command. You can do it using command line also. So all these techniques or technology, they support CLIs also. You can use commands also and do a lot of processing. And real-time processing or scheduled batches or hybrid mode, both real-time as well as batches. So all kinds of processing are supported. Then synchronous versus asynchronous. This is very similar to the synchronous process versus asynchronous process you have studied in so many other courses. Okay, so some things where in synchronous there should be acknowledgement sent for every single request sent. In asynchronous, it can be done in kind of it can be done without waiting for acknowledgement for every single request. Okay, so synchronous will be slower, asynchronous will be faster, and synchronous will be more reliable because it expects acknowledgement. Acknowledgement will be sent for a request. Asynchronous may be less reliable, but it has other mechanisms to verify whether the requests were processed correctly or not. Okay, so this you know from operating system and other um, courses. Okay, so that is layer 4 data processing. Then the last one is the data consumption. Okay, let's say the processing is all done. Then where do you store it? Like I said, it can be stored in cloud. It can be stored in various. Um, uh, can be exported to various targets, various sources. It exported web also. If there is an interface built, web interface built to process the data that was processed in layer 4, it can display it on the web also. Or it can be this business processes, business, I think intelligence. So they all have various tools. Those are business related tools which will represent the data for business people. Okay, like for example, you can take the same example where the products are ordered by different customers, right? So they can get the report finally showing, okay, age group between 20 and 25 orders these products frequently, or 25 to 30 orders these products or uses these products, watches these types of movies, they download this kind of data, all kinds of information. Okay? Now for knowledge discovery, so to learn more about that particular data set which was processed in layer 4. Okay, so that the data can be made available for all those purposes. Okay, and visualization, which we'll cover in module 5. So how to visualize the data in terms of even it can be as simple as a pie chart or a bar chart, some kind of graph, or it can be sophisticated graphs also. Okay, with even animation added, all those things, very interactive type of graphs and reporting. So anything can be added. Like if you look at this charts, right, used for currency conversion from, let's say, one foreign currency, US dollars to Indian rupees, like that, or stock related data represented in graphs, right? They are all kind of interactive and real time. Okay, so even for currency converter graph, it will show the currency exchange rate. You tried, if you have not seen it, you just Google currency converter. Let's say put USD to INR, Indian rupees. You will get a graph. So point your mouse cursor at different points. It will tell you the rate for that particular date. So if you want to see it over a period of week or days or months or years, it will show all the data. If you want to see the exchange rate for USD to Indian rupees on, let's say, April 20th, 1995, something like that. It will show. So all those data are, are like kind of processed and they are consumed this way and reported this way. So that is the job of the layer 5. Of course, you need a specific tool to do all those things, okay, to report data in a particular format and so on. But nowadays they use all these big data tools and ML tools and with cloud to report all this historical data as well. Not only real time data, but historical data. Okay. All right. So any questions? Till now, I'll pause here. Hope you are still there. So we have about 13 or 14 students. Um, Let me see if you guys are awake, if I am audible, if I am, and so on. Let me just pick somebody. Chinmay. Chinmay, was it clear? Any questions on the 5 layers? Chinmay, can you speak up? Are you there, Chinmay, or sleeping or doing something else? HOD said if students don't speak up, they won't get attendance. Maybe I should also have that rule. Chinmay, you're not answering. Okay, let's see somebody else. Praveen, are you there? Did my explanation make sense to you? Was it clear? I don't know who will answer now. I think I'll go back to Shilpa or Nandita. Nandita or Shilpa, who was answering?
Sir, it's Nandita.
Nandita, yeah, was it clear?
Yes, sir.
Or audio audible, then explanation, everything?
Yes, sir.
Okay,
It
thank you.
was
You will
fine,
get
sir.
100% attendance. Okay.
Praveen,
Thank you, sir.
So,
yes, sir.
sorry,
Praveen
somebody
is on the
else
call.
speaking?
I'm sorry, I couldn't answer
Sorry,
you.
you are not. Praveen, yeah, tell me again. You're not audible that much.
So I'm just on the call, but sorry, I couldn't answer you when you called my name.
Sorry, it's too low. Can you speak up
Okay, sir, I was
louder?
also in the call, but sorry, I couldn't answer you when you called my name. So
No, so I'm able to understand little bit, but not that clearly. And I'm not wearing headphone today. So, okay, that's fine. So, if you don't have any question, then let's move on. It should be simple to understand. You guys are in PG, but I'm only concerned about students who have not studied big data in UG. So, how much of it can be absorbed? That is my question. Anyway, you can read up. That is
Excuse me,
only. Sorry, somebody said something. Okay.
sir.
Anyway,
Sir,
in the
what is
sorry.
data ingestion?
Yeah,
Data
it is that it
ingestion.
is data being injected into this environment or data being brought in or acquired. That's all. Nothing, no other extra meaning for that. So either data can be ingested actually, not injected, ingested or acquired. You can say acquired. You can pull it. See, you can acquire data by pulling it, or somebody can push it. So pull it or push it or acquire it. That's all. Okay. So the explanation is also given in all these slides, so you can easily follow it. Okay. In case if you didn't understand something, you can always um, read these slides, or you can refer to the relevant section in the textbook. All right. How much more time we have? 5 more minutes. Huh? I'll probably stop here because this is another topic, so I can do it tomorrow. So tomorrow again, please be on time. Okay. Start at 10:40, and let's see if we can finish. No, I don't think we can finish all this. Okay, so because the first chapter is all very theoretical, introductory, basic topics. Okay, so I can go faster also, but that's why I was. My concern is like all of you are not familiar with basics of big data, so I don't want to rush also. All right. So again, I'll check one more time. So I believe there are only two students who took big data in UG. So is there any other student who knows or learned big data? Please speak up, or you can when we meet next week. Hopefully there'll be offline classes. I will check again because if you have not taken basic big data, right? So I need to give more explanation, and it'd be difficult for you to follow, especially from module 2. Follow the topics from module 2. So you will have to do a lot of reading, and I will have to give a lot more explanation. Okay, I'll check with you in person in the class next week. But you can always message me or email me if you have taken. At least I'll get an idea how many students are already familiar with big data basics. And hands-on, I believe nobody have hands-on experience because that's what I was told by the big data teachers in Cambridge, who handled your big data course in UG. Right? You didn't have any hands-on or experiments. You didn't do any experiments. Okay, so here I will make you do some experiment. That way, it'll be more value add. It'll be useful for you for your job, for your internship, for your future projects. Without hands-on doing cloud or big data is not that helpful at all. By just knowing theory, it's not helpful at all. In cloud, right, you have to get your hands dirty by at least logging into AWS platform or GCP or whatever, Azure or whatever, and do something like create instances, run instances, create VPC, then create buckets, then store some objects, right? So create use some REST API commands like that. You have to do something. Otherwise, just studying about cloud doesn't help much. Same thing here. So we'll try to use the tools. So that will all be possible only in the offline class. Okay. All right. So that's it from my side. If you have any questions, let me know, or we will close the session. All right. I'll talk to you tomorrow. So please join and be on time. Okay. All right. Thank you.